In this video, I'm going to give you a clear idea about sigma and pi bond, which type of orbitals form sigma bond, which type of orbitals form pi bond, and in which conditions these bonds are formed. First, sigma bond. Sigma bond is formed by end-to-end overlapping, means two ends of the orbitals overlap along the internuclear axis. This is a very important point, along the internuclear axis only. So how it can look like? It can be s and s orbital. The internuclear axis here is like this, and the axis in chemistry, this horizontal axis, is z-axis. Another possibility of end-to-end overlapping is one s orbital, another p orbital. But as I said, along the axis, internuclear axis, it will be z-axis. So it means the p orbital here is pz. Only pz can form sigma bond, not any other p orbital. Another possibility, two hybrids are there. In hybridization, we know that two hybrids, if formed and they overlap along the internuclear axis, horizontal axis, z-axis. In this case also we will get sigma bond. Another possibility, one is s orbital, another one is hybrid, but both are along the internuclear axis, that is z-axis. Another possibility, both are pz orbitals. They will be along the z-axis, that is internuclear axis. They will form sigma bond here by overlapping, end-to-end overlapping. Another possibility, one is p orbital along z-axis and the other one is a d orbital. But this d orbital is dz square, and dz square is along z-axis. It means both will be on internuclear axis and they will be overlapping by their ends. So again sigma bond formed here. Another possibility, both are dz square. So here dz square, both will be along the z-axis, internuclear axis. So the overlapping will be end-to-end overlapping. Another possibility, both are dx square minus y square. There are total 5 d orbitals, but remember only dz square and dx square minus y square can form the sigma bond. In this case, both dx square minus y square type come closer and there is end-to-end overlapping. Again sigma bond. This figure is itself very important because quite a few times I have seen questions in competitive examinations such as, which out of the following cannot form sigma bond? Which out of the following can form sigma bond? Which out of the following can form pi bond or cannot form pi bond? So if you can remember in which particular cases sigma bond is possible, these type of questions will be very easy. This type of bond is present in all compounds or hybridizations. So whether I have sp3 hybridization, sp2, sp, sp3d, sp3d2, in every compound, in every type of hybridization, the sigma bond has to be there. The only exception is in molecular orbital theory when we explain that C2 molecule exists, but here pi bond is formed first. Otherwise, sigma bond is always formed first. For more details about the C2 molecule, you can watch my video on molecular orbital theory. So whether you have ethane, ethylene, acetylene, in all the compounds, the sigma bond will always be formed and it will be the first to be formed. This overlapping is also known as head-on overlapping. This end-to-end overlapping is also known as head-on overlapping. It looks like that two heads are overlapping here, that's why. It is also known as axial overlapping because it is along the internuclear axis. So all these three names, end-to-end, head-on, and axial overlapping, all these are same thing. Now the pi bond. Pi bond is formed by side-wise overlapping. This overlap is also known as parallel overlapping or lateral overlapping also. So parallel overlapping, lateral overlapping, or sideways overlapping also. So sideways, parallel and lateral are same thing. This is how the overlapping takes place. So you can see that the two p orbitals are parallel to each other, and when they come closer they overlap, and it is called p pi bond. It is pi bond. Why it is called p pi? Because both p orbitals are taking part in overlapping. Now this p orbital can be px. So if it is px, the other one will also be px. So px orbitals of two different atoms, when they come closer, they can form pi bond. It can be py also, not pz. Pz will always form sigma bond. Px and px will form pi bond, or py and py will form pi bond because they will be parallel. So if I have for one atom and for second atom, this is z-axis and this is y-axis, this is x-axis. So if I have, say, p orbital along z-axis, so it will be pz, and here also I have p orbital along z-axis, it will be pz. When they come closer, this will be head-on overlapping, means sigma. But if I have p orbital along y-axis of one atom and p orbital along y-axis of another atom, when they come closer, it will be parallel overlapping. Similarly, if I have p orbital along x-axis of one atom and along x-axis of another atom, when they come closer, there will be pi bond formed. So whether it is px or py, in both cases it will be pi bond. In pz, it will be sigma bond. Now another possibility is that I have p orbital of one atom and d orbital of another atom. In this case, pi bond will be formed by side-wise overlapping, but it will be called p pi d pi. The reason is very simple, because one orbital is p, the other orbital is d. Another possibility, third possibility, is that both are d orbitals and they come closer, there will be side-wise overlapping, lateral overlapping. In this case, because I have both d orbitals, I will call it d pi bond. It is a pi bond. The reason I am calling it d pi because both are d orbitals. Now the question, how many sigma and pi bonds are present in each of the following molecules? The first one, for such questions, you will always draw the expanded form of the structure. Expanded form means all the bonds you need to show. So the expanded form of this one will be HC, and then here triple bond. Then this carbon is there. With this carbon, I have this C attached here. But remember, 3 bonds already here. So it means there will be only one bond here. Carbon has maximum 4 covalency. Then I have CH, this part, then double bond. Again I have CH, then I have CH3. Now I need to count all the bonds here. Remember, in double bond there is one sigma bond and the rest pi bond. In triple bond there is one sigma bond and rest 2 pi bonds. So if I count the sigma bonds only, there will be only one sigma bond, whether it is triple bond, whether it is double bond, there will be only one sigma bond. So number of sigma bonds here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 sigma bonds. But if you are asked how many CC sigma bond, how many CH sigma bond, so you can see here sigma bond between carbon and carbon. Here sigma bond is between carbon and hydrogen. So we can say out of this, C sigma bond and CH sigma bond. CC sigma bond 1, 2, 3, 4. These are between carbons. So 4 sigma bonds are between carbons, And how many between carbon and hydrogen? 1, 2, 3, 4, 5, 6. Total 10. Now consider pi bonds. Pi bonds here, 1 sigma bond, rest 2 pi bonds. In double bond there will be pi bond, 1 sigma bond, 1 pi bond. It means total 3 pi bonds. So pi bonds total 3. Here these have to be between carbon and carbon. You can't have double bond, triple bond between carbon and hydrogen. So it has to be carbon and carbon. Now these can be, however, differentiated or segregated between triple bond or between double bond. So out of these 3, carbon triple bond carbon has 2 pi bonds and carbon double bond carbon has 1 pi bond. Next, again expand it. So CH2 double bond C double bond CH CH3. Here again we will count the sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9. So sigma bonds total 9. Now out of these 9, how many between carbon and carbon and how many between carbon and hydrogen? So between carbon and carbon, if I see here, 1, 2, 3 only. Between carbon and hydrogen, 1, 2, 3, 4, 5, 6. So between carbon and hydrogen, total 6, and 3 plus 6 we have 9. Now pi bonds. Here I will have 1 sigma and 1 pi bond. Here in double bond I will have 1 sigma and 1 pi bond. So total pi bonds will be 2, and both will be between carbon, and that is double bond carbon.